All right, now here's a third situation. I want to find the slope-intercept form of my equation again, but once again it's a different scenario. And this time we're going to find the equation, but just from 2 points. So they're asking us to imagine here a straight line that goes through these 2 points. So one way we could do this is to actually graph it, but I think we can save ourselves a little bit of time, because if you notice where this point would go, 0, 7, that would go on the y-axis up here at 7, which means not only this is just 0, 7 as a point, this actually happens to be the y-intercept. Okay, now of course the other thing we need, like on all the other problems, is we need the y-intercept, which in this case we found. It's 7, because if x is 0, y is 7, so that means that's the point right here. But we also need slope. But if you think back to a previous lesson that we did, we know a way to find slope. We could graph it, but we don't have to. We've got an actual formula for finding slope when we're given 2 points, and it's this one. y2 minus y1, which gives us the change in y, or the change in the rise, over x2 minus x1, which gives us the change in the run. So if I think of this as x1 and y1, and I think of this as x2 and y2, I can just plug this into this old formula that we were using in a previous lesson. So y2, which is 13, minus y1, which is 7, which gives us a rise of 6. Then x2 minus x1, which is 3, we have a run of 3. And since we write equations in fraction form, slope in fraction form, let's reduce it. So 6 over 3 reduced down to 2 over 1, or just 2. Okay, so this graph, if we were to do it, would have a rise of 2 and a run of 1. Okay, but again, we're not looking for the graph, we're looking for the equation. So we go to our y equals mx plus b, where m is the slope, which we just figured out is 2 over 1, or just 2. So y equals 2x, plus our y-intercept starting point, which was 7. So there's the equation that would go with this scenario. Okay, this line would go through these 2 points. All right, so that's a bit about slope-intercept form, and again, it's this idea of literally knowing it backwards and forwards, that we can use slope-intercept not just to create the graph, but also to come up with the original equation.